So the next part of the global issues unit we look into is what causes climate change. So we know from the introduction it's an increase in greenhouse gases in our atmosphere. What exactly causes the greenhouse gases to be in our atmosphere? And that's what we're going to look at in this lesson. So there is both physical and human causes, and it's important to know that because climate change has actually been happening for millions of years through these physical causes. Humans in the last 200 years have just added to that by the burning of fossil fuels and the activities that we do surrounding that. So, like Akina says, the physical causes have been around for millions of years and they've always existed and they've been responsible for the Earth heating and cooling periodically for the whole entire history of the Earth. Think about the last ice age, which only ended about 10,000 years ago, which in geographical terms is not that long. So, the big one, and I'm going to move myself about. I might be jumping about in this lesson, so bear with me. Just try and follow what I'm saying and not where I am. So, sometimes the sun's output varies from time to time, and we're going to focus on solar flares. So, what happens is solar flares is an increase in activity on the sun, either mini explosions or whatever. But what it leads to is it leads to an increase in the sun's radiation output. So, what's happening is more of the sun's energy is being put out into space, which means more of the sun's energy is reaching Earth, which means that energy in the form of heat is allowing our temperatures to rise temporarily for a small time. It's long enough to be classed as climate change because of the time it takes all of this energy to travel to Earth and so on. So solar variation, increase in solar activity leads to higher temperatures on Earth. So the next climate change we're going to look at, and it's an interesting one, is volcanic eruptions. Now, volcanic eruptions can throw loads of stuff into the atmosphere and block out the sun. Now, it doesn't make everything completely pitch black. The last and biggest example of this was in 2010 when a volcano in Iceland erupted. It threw millions of tons of ash and dust into the atmosphere, which over the course of several weeks spread right around the world. In fact, it stopped aeroplanes flying. People who were meant to go on holiday couldn't go. People who were on holiday were stuck. It was pretty mental. But what happened from that was, because of this new gas and dust into the atmosphere, it blocked the sun's energy from hitting the surface and heating it up. So it only let only let some of it go by, a lot less than normal. So the sunlight is blocked by the gases, it's reflected back into space, which means we were actually cooler for a period of time until the gas dispersed into space. So volcanic eruptions cool down the Earth by blocking out some of the sun's energy from reaching us. The last physical one we're going to look at is a change in ocean currents. So we're going to focus on the UK because it's really valuable to us. So actually some of the ocean currents, and this is a bit of a very simple diagram, our water, as we can see from this red line, starts kind of as warm water. It's very much heated up in this area here near the equator. Alright. What it does is it then travels up the Atlantic Ocean and then pings round towards the UK, and we are here. Now this warm water brings with it warm air, and this warm air keeps us much warmer than countries that are on a similar kind of level to us. So if we think about Norway and Sweden in the winter, they tend to be kind of under loads and loads of snow. We are not. Now Norway and Sweden so on are here. So we theoretically should be pretty cold in the winter, covered under loads of snow all the time. Think about the same with Canada. But we're not, and the reason we're not is because this warm water carries with it warm air and keeps us warmer before it comes back down. Keeps Canada nice and cool, and then goes back into this kind of nice kind of water flow system. So warm water brings warm air, keeps the UK warmer. So human causes, this is the things that me and you do, either through what we buy or actually physically putting greenhouse gases into the atmosphere. So burning fossil fuels for transport, so for me it's my car, for industry, for power, so all your electricity at the moment, and it's slowly changing, which is good, is produced by burning of fossil fuels. Quite recently, Scotland has a few days where wind power has produced all the electricity, but depending on how much we use, it's usually coal powered. We've got worldwide deforestation, so cutting down trees, which store carbon dioxide, burning the trees, which then releases the carbon dioxide into the atmosphere. Car exhausts, power stations, nitrogen fertilisers to help us grow food, all of these things put greenhouse gases into the atmosphere. One for the younger generation is things like deodorants and makeup sprays and aerosols and air conditioning and producing different packaging, all produce CFCs, which put greenhouse gases into the atmosphere. And methane produced from rice fields, landfill sites, and cattle farting and burping. So, CFCs are really bad for depleting the ozone layer, which allows more of the sun's energy to get in. CFCs are in or were in hairspray, fridges, things like that. It's been banned in some countries, so it's not as common, but still exists. So any kind of spray, deodorant, if you're buying any, make sure it's CFC free. If you can't, buy a roll-on, things like that. So with the population growing, and we know this from our population lesson, we need to feed these people. And one of the most popular dishes and one of the biggest kind of crops grown in the world is rice. But when rice is produced and grown, it produces methane. So the more rice we grow for the growing population, the more methane we produce into the atmosphere, which leads to more greenhouse gases and then inevitably climate change. So these are the reasons for climate change, both physical and human. What I would like you to do is jump into your OneNote and complete the table explaining to me how each of the physical and human causes lead to climate change. Now, what you might want to do is rewatch this video and pause it and kind of play the certain parts and pause it, fill in your answer, watch the next part, pause it, and so on. But if you do have any questions or any issues, please feel free to jump onto the post tab of this Teams and ask a question, and somebody in here will be able to answer it for you.